All right, so we decided to record the video with a Kendall POV. So this is the height that Kendall is at when she's sitting down. In fairness, this is not her height standing up, okay? We don't want to give a false idea to our YouTube audience. So we have this at the same level as Kendall's eye line. Why? Because why not? And so we did what the seniors asked for. Okay, Kendall didn't ask for it. Michael did. But anyway, it's a little bit of a different angle than we're used to. And so if you don't like this angle, you can feel sorry for Kendall and send cash. All right.
PayPal.
If you send it to if you send me through PayPal, I will make sure Kendall gets a cut. Well, I have to charge a processing fee, Kendall.
Yes, sir.
I'm going to offer the service, right? Plus PayPal takes their fee, and then I take my fee. So if you send $100, PayPal takes $10, I take $20. Kendall still gets $70. So anyway, yes. And then she'll have to report it on her income tax. All right. Anyway, we have a quiz coming up in just a moment that they don't want to think about, but we do. So we need to take a look at the homework problems. Problem number 8 on page 399. And go ahead and read problem number 8 for us. If you would, Kendall, nice and loud as the camera is right there near your face.
Two resistors, R1 equals 12 ohms and R2 equals 15 ohms, are connected in parallel. The combination is connected in series to a third resistor, R3 equals 18 ohms, and to a 148 V battery. Draw the volt battery. Draw the network and then calculate the equivalent resistance, the current leaving the battery, the current through each resistor, and the IR drop across each resistor.
All right, so the first thing we should have done was draw the circuit, and a 148 volt battery. That's new to me, but you know what? We don't argue. It's a really big battery. Let's see, it's going to go to 2 resistors, and we need a big battery because these are pretty substantial resistors in parallel. Okay, so maybe we draw 2 resistances, maybe something like that. Okay, so they're in parallel. And then this combination is connected in series to a third resistor. We could come off this way and put a third resistor. I could just come down and put a third resistor. Something along those lines. So my resistances were 12 ohms. That's a terrible ohms. 15 ohms and 18 ohms. Did we have something like this for our network? All right, the first thing we needed to find, of course, was the equivalent resistance. And kind of talk me through what you... I just realized this lectern really blocks a view for Kendall. It blocks like the whole bottom of the half of the chalkboard.
How do you feel about that?
Now we can see the chalkboard.
Yay!
She's like, it took him 6 years to figure out what I needed, but he finally understands my needs.
You're welcome, Kendall.
Oh my, anyway, okay, so walk me through finding the equivalent resistance here, if you would. Kendall?
The 15 ohms and 12 ohms.
Okay, we have those in
parallel.
So
You add the reciprocals.
good, and
Take the reciprocal. 6.6 repeating.
all right.
And then you add the 6.6 repeating and the 18.
Okay.
To get 24.6 repeating ohms.
And then we do need to round this off. I'm looking at sig figs, and I'm seeing 2 sig figs. So we'll say approximately
25 ohms.
ohms. All right, but we're not going to use that number. We're going to use the 24.6 repeating. Second thing we always find is the total current that leaves the battery that passes through this network. And how do I find the total current?
You do the voltage divided by the 24.6.
And hey, this works out nice.
6.
But we technically need 2 sig figs, so we'll have to say
6.0.
Now, the difference here is I didn't make this problem up, so it works out beautifully. I make up the problems. There's no telling what happens. All right, so then we're ready for our chart. We list out the resistances. There's only 3 of them. We list the current that goes through each resistance, and we've got the IR drop at each resistance. We list them as 12 ohms, 15 ohms, 18 ohms, and I'm going to group those two together. All right, what should we fill in first, Kendall?
The 18.
Okay. What do I already know about the 18 ohms?
The current is 6.
Good, because all 6 amps has to go there.
Um, 24. Or no.
You hit plus instead of times.
Um,
IR is R I times R, you know that, so.
108. Volts.
I guess technically I have to round that off to 110 volts, which is a little obnoxious, but you know, whatever. By the way, simple math. How many volts are still there? 40 volts. Where do the 40 volts get lost? Up there. Now, you could, that's one way you could approach it. Another way is to say, hey, what do I know about this whole thing, Kendall?
6.6 ohms.
What else do I know about this whole thing?
The current
Is
6.
6 amps. And if you multiply, you're still going to get 40 point volts that we knew we were going to lose here. Okay, so there's two ways to approach it. If it's this simple of a network, I'm used up 108 volts right here. All the rest of it's parallel, so all the rest of it's got to be the 40 volts. Now, that 40 volts at the whole thing, Kendall, is the voltage of the whole parallel set is the voltage through each branch. So each branch, 40 volts. Let's just take this first branch, the lower branch here as I've drawn it. 40 volts, 12 ohms. What does that tell me?
0.3. Hold on. I think I did the wrong way. 3.3 repeating.
3.3 repeating what? 40 volts passing through of force pushing through 12 ohms is able to push how much current?
3.3 repeating.
3.3 repeating. Not ohms.
Ohms.
Oh, not ohms. That's resistance. We
Oh,
have voltage. We have volts, ohms, amps. Amps. So that means the 12 ohm resistance, then this whole branch gets 3.3 repeating amps, which means, well, that means that this one resistance also gets
3.3. Yeah.
and we'll just say round to 3.3 amps. But we'll use the 3.3 repeating to get the IR drop, which we could kind of have figured out without the help.
40.
The 40 volts that we already knew, 40 point volts for the sig fig's sake. Then we come up to the top branch as I've drawn it.
Uh, 2.6 repeating. Amps.
So therefore,
The current is 2.6 repeating.
or we'll round to say 2.7 amps at the 15 ohm resistance. And again, pretty intuitive, but the IR drop's going to be 40 point volts. All right, Audrey, Michael, good to go? Kendall, good to go?
Mm-hmm.
All right. Kendall used her homework pass, lest you be like, why is he picking on Kendall? He lowers it to her point of view and makes her do the whole problem by herself. He's such a mean person. Kendall, stop clapping. All right, no, she used a homework pass. I want to make sure she gets the benefit of the homework, even though she was not required to do it last night. Hey, today was the last day to use it, right? So use it or lose it. All right, I'm not begrudging it. Okay, let's go ahead and read number 9. Kendall.
3 resistors of 2 ohms, 4 ohms, and 6 ohms are connected in series. Another 3 resistors of 3 ohms, 5 ohms, and 7 ohms are also connected in series. These two sets are then connected in parallel to a battery of 18 volts. Draw the network, then calculate the equivalent resistance, the current leaving the battery, the current through each resistor, and the IR drop across each resistor.
All right, so we start by drawing 3 resistances in series. Something like that. Then it says there's another set of 3 resistances in series. And it says these 2 series are connected in parallel. And then this parallel is connected to a battery. Poorly drawn, but you know, you get the idea. Do we have something like that? We could have, by the way, just come straight down off of this. We didn't have to make a loop off of it. But, you know, anyway, so there's kind of our general idea. So we've got resistances of 2, 4, and 6. We've got resistances of 3, 5, and 7. This one's a little odd, but the battery itself was 18 volts. Kendall, what do we need to do here?
You add the series ones at the top.
All right, to get?
12 ohms.
So this branch is really 12 ohms of resistance.
And then you add the bottom one to get 15 ohms.
This seems vaguely familiar. And so if I've got 12 ohms in the top branch, 15 ohms in the bottom branch, how much resistance do I really have?
16.6.
Not 16.6.
Oh, 6.6.
6.6 repeating. She's like, wait a second. We just had a 12 and a 15 together earlier. Yeah. And so, but that's all the resistance there is. There are no basic series anywhere. So the equivalent resistance really is
6.6.
which, let's see, is it 2 or 3 sig figs? It's 2 again. So we'll round it off and say
6.7 ohms.
if I say not ohm. All right. Then we need the current.
Uh, 2.68.
Did you do 6.7?
Yeah.
You tried to cheat. 6.6.
0.370.
That's not right. Oh, remember voltage divided by resistance. 18 divided by the 6.6 repeating. Third tries the charm.
2.7.
Comes out evenly to 2.7 amps. Once again, that's an awfully nice number. All right, you two good to go on the initial steps. All right, so we list out the resistances of 2 ohms, 4 ohms, 6 ohms. Those are all together. 3 ohms, 5 ohms, 7 ohms. Those are all together. Audrey's OCD is triggered. It's still triggered. There we go. Is that better? Slightly better. Okay. All right, Kendall. There's nothing easy to just straight plug in, is there?
No.
But we do at least know this. There's 18 volts. And it all goes at once. Another way to look at it is there's 2.7 amps. And all 2.7 amps goes through this. And if you were to multiply, again, that's obviously going to give you 18 volts. So all 2.7 amps hits this because all 18 volts, this doesn't usually happen. Usually there's at least one series resistor somewhere. There isn't. So all 18 volts gets used all at once right here, which means since that's the voltage of the whole thing, it's also the
Current. No.
18 volts is voltage of the whole thing. That becomes the voltage through each branch. So once you get that voltage number, put it at each branch. That's the key that gets the parallel set going, is recognizing once I got the voltage, put it at each branch. Because each branch you've already got the resistance written in. Once I got voltage and resistance written in, it's going to lead you to get the next thing for each branch.
.6 repeating.
Careful, V over R. Remember, I equals V over R. Might not hurt to, the two ways we always use it are these two. We never actually end up finding the resistance. V over I just doesn't end up happening in our networks. So we always end up using the V equals IR over here. And in here, we often will find I equals V over R.
1.5.
So the top branch gets 1.5 amps. Now, once our 2.7 amps comes here, comes here, comes here, now it has to make a decision. Which way am I going to go? And it splits. 1.5 of the amps goes up here. And once the 1.5 amps has made the choice to start down this track, it's direct current, it all has to go this way. So,
the 12 ohms.
they all get what?
1.5 amps.
So I can come to the chart and for all of them, 1.5 amps. Audrey, Michael, did you put the 1.5 amps for all three of those? Good. Kendall, does that make sense?
Mhm.
And now that I know the 1.5 amps for all of those, I can go ahead and get my,
IR
to be,
3.
I'm going to say 3.0 volts,
6.
0.0 volts,
9.
0.0 volts. And it all adds up to the 18 volts that the branch got in the first place. Then we come to the lower branch. 15 ohms, 18 volts.
Uh, 1.2.
And we almost could have figured that out without doing that division because there's 2.7 amps, right, evenly. If 1.5 go here, that leaves 1.2 amps to go here, right? So 1.2 amps starts a trek down this pathway. And once it goes into this branch, Kendall,
It goes through it all.
so
Each one gets 1.2 amps.
and that tells me the drop at each resistance as well.
3.6. 6. And 8.4.
And once again, you add these together and you'll get exactly 18 volts used up. Did we have both of the homework problems correct? All right, so you two feel good to go, confident. Kendall, you've done it just now. Bulk for a minute here, but it seems like you got it really well on the bottom branch down there. Feel like you're good to go on networks. All right, so the terror you felt when I first showed this 3 days ago, feel like you've overcome and you now understand? Questions at all? All right, well, let's take a quiz. Clear your desk, except, this looks really weird. Clear your desk except for a clean sheet of paper, a pencil, and a calculator. Clean sheet of paper, pencil, calculator. I'll say this, if you want colored pens for marking things, I would not be opposed to that, or highlighters for marking and circling and grouping. Colors can sometimes help when solving these. You're welcome to have those out if you'd like.
No.
At the very least, how about a pencil, a sheet of paper, a calculator. I'm gonna have to raise this back up. You don't have to see the chalkboard now anyway, that's the only reason I lowered it. It's a little higher than I usually have it. Alright. First and last name at the top of your paper. And today's date, which is 5/12/23. This is quiz 29. And as I mentioned earlier, the last quiz I'll ever give you. It's always so sad that there's no more torture. All right. Quiz 29, or you can put quiz the last. You see, you'd be like, I'd be a lot more emotional if there weren't an exam coming in. Yeah, I know. All right. Pretty straightforward quiz. You've got two networks. Find equivalent resistance, current from the battery, current across each resistor, and the IR drop. Do what we've been doing. You've got two different networks. Solve them. We'll come back after the quiz is over and done with, and we'll begin our exam review.